Now let's take a look at the RBD activation, how we can animate our RBD activation attribute to create a crumbling effect. And right now here if I hit play, and here you will see our wall is falling, and I don't want that. Let's fix this falling wall issue. And to fix this we need to go into the RBD configure, and maybe I'm going to just duplicate my all of the setup, that is our basic setup. I'm going to just duplicate all of this simulation network onto the side, and let's play around with these settings. First let's go into the RBD configure node, and we have the option to enable the activate. Let's enable the activate, which means that right now all of our simulation is active. We are saying this activate to 1. Nothing will happen, nothing has been changed. If I were to hit play, we get the same effect. But onto the RBD configure, we also have some other option. Right now they are cutting off. We need to make this parameter bigger, and here as you can see we have the option to enable the use bounds. Let's enable the use bounds option, and right now I cannot see the bounds. Let's go into the RBD configure and let's view the RBD configure so that we have the guides, activation guides. And right now I still cannot see my guides. Let's scroll up, and in here we have the visualization, and right now visualization is set to none. Let's change this to active. And now we can see the active. Right now all of our wall geometry has been inactive, and that is because of the use bounds node. The bounds, we can control the bounds. If you come over here, it says bounding type. It is expecting the bounding geometry, which means we need to plug the bounding geometry in here. And if I were to hover over to the inputs, the last input is for the static bound, which means we can create our bounding geometry, or we can go into the RBD configure and onto the bounding type we can change this to bounding box, and it will create a bounding box geometry, and in the viewport the box has been visualized. I can increase the bounding box size, and some of these fractured pieces are turned into green. All of these green means that they are active, and the black means that they are inactive. I'm going to play around with the bounding box, and if I were to hit play, let me activate my camera view again. Let's go into the bullet solver, and here you will see that our wall is not breaking, and that is because, let me change the visualization. Why it's not visualizing? We need to go back on the very first frame, and maybe we need to activate the manipulator, and now we have the visualization back. All of these black mean that they are inactive. When the ball hits the inactive, the ball still collides, but they will not move because they are inactive. But I want the reverse effect, and to create the reverse, first onto the bounds, right now we have these bound. I'm going to say that all of these geometry pieces that are in the bounds, let's not make them active. Onto the activation, I'm going to change this to 0. And now we are creating the reverse effect. Now all of the geometry that is outside of the bounds are going to be active, and onto the bounding box we have the black pieces. These blacks mean that now they are not active. They will still act as an collider, they will still be in this simulation, but they will not be affected by any forces, which means I can go into the bullet solver, and now this ball will going to break this wall. And here you can see now our wall is not falling because we are basically pinning this base geometry, and because we have this constraint. And if you do not add the constraint, if I'm going to just, let's say, bypass the constraint node, and right now it is throwing an error, we need to remove this constraint geometry in here. And if I hit play, and if I'm going to visualize this RBD configure node, here as you can see we still have the same active. The greens are active and the blacks are inactive, which means that all of the green wall will going to be fall apart. And here as you can see, our green pieces has been falling apart, and all of the pieces that are inactive, they are just staying there, and they will just only collide with all of our simulation. When we have created the glue constraint, let's add the glue constraint and connect this onto our this constraint geometry. Now this glue constraint will going to be hold or these pieces together. Let's go into the bullet solver again and let's see the result. And here you will see when the ball hits, if the force is greater than the breaking threshold, if I go into the RBD constraint properties, here we have the strength. If the hitting threshold is higher than their constraint strength, these constraint will going to be get broken, and we have this breaking wall effect. And maybe let's animate our this activation attribute. Right now we are using these static activation by using these bounds. To better understand this active, let's not use the constraint, and for that maybe I'm going to just create another example onto this side. And to create this, I'm going to create a scope geometry. Let's add our lovely scope, and same thing, I'm going to just move my scope geometry a bit up, and I'm also going to rotate this like so. Let's fracture our this scope geometry, and for fracturing we need to scatter some point. For scattering, first I'm going to convert this into volume by adding the ISO offset. Let's connect this onto the ISO offset. Let's increase the uniform sampling to create a more high resolution of our fog volume. Let's add a scatter node. Now we will going to be scatter points onto the inside of our geometry as well. Onto the scatter, maybe let's uncheck this relax iteration option. Now I'm going to use a Voronoi fracture node. So let's add a Voronoi fracture. That is the geometry I'm going to fracture, and these are our Voronoi points. Now we should see the fracturing, and right now it's calculating, and once it's done we should see the fractured, and our scope geometry has been fractured. I can confirm by adding the exploded view node in here. Let's add an exploded view and let's view this, and here as you can see we have our fracturing going on. Now let's pack our geometry, and for packing I'm going to use the RBD configure node because we have the name attribute. If I go into the Voronoi fracture, we have the piece attribute. You can define your piece prefix, and by default this Voronoi fracture will create name attribute. We just need to connect this onto the RBD configure, and RBD configure will use the name to pack our geometry. And after packing, we are working with points. If I go to middle mouse button, here you can see we only have 1000 points because now we are packing our geometry. Now let's create our activation attribute, and to maybe better visualize our active attribute, I'm going to say extract all points, which means I want to remove all of the primitive, these pack primitive, but I'm just going to keep the points. And here we have our fractured points. And let's create our activation, our growth activation attribute. And for that, same thing, I'm going to use this sphere. Let's add a primitive sphere because we actually do not care all of the mesh geometry. And after that, maybe let's add a transform node, and let's template the transform. Let me template this. Select the node and press enter in the viewport. And I'm going to place my sphere in here. I want to start the activation from here. And now we need to create the active attribute, and we can create this onto the RBD configure. I'm going to just enable the active, and by default I'm going to change this to 0. We have all of these pieces inactive. And onto the side I'm going to create another active attribute. So let's create an attribute create node. Let's connect this, and onto this one I'm going to say I want to create an active attribute. Let's type the name of the attribute, and it is a float, and I'm going to change its value to 1. Now let's transfer this attribute. We can do so by adding the attribute transfer node. Let's add this, and that is the geometry. First maybe let's use these points only, and let's connect this in here. Let's go into the attribute transfer. uncheck the primitive, but let's only define the active. Let's go into the condition, and now we just need to animate this parameter. And right now I cannot see my active, so let's add a visualizer so that we have some visualization. And to create the visualization, let's click on this I button. You can click on any of these attributes, and here you can see we have this switch, and that will just create a visualizer. And I'm going to just visualize my active. Let's click on it, and here you can see we have the visualizer added, and all of the red points are active and all of these purple points are inactive. Let's go into the attribute transfer node and let's animate this parameter. And first I'm going to add a key in here. We will start with the 0. Let's go a few frames forward, and I'm going to keep adjusting this until we see all of our point active, and we have all of our point active. Let's add another key, press and hold the Alt key and left mouse button. Let's scrub our play bar, and here we have our animated activation. Let's hide the visualizer, and we can do so by clicking on this I button, and let's click on this button again, and that will just not add the visualizer, and now we are not visualizing it. Let me untemplate my transform node, and by the way, because we have all of these animation, we can just go into the transform node, select this, press enter, and you can place sphere anywhere and it will going to be start activating from that location. If I were to enable my active, and now we should see that our activation will start from here. And same thing, I can just click and I can place it anywhere I want. I can maybe start the activation from there. Let's scrub our play bar, and here as you can see it is very procedural setup. I'm going to just undo this and place it the way that it was. I want the activation to start right here. Let me hide the visualizer, click on this, and let's uncheck the active. Let's untemplate this. Now that we know that our visualization work, we don't need the extract all points. I've just added that so that we can visualize, because when we have the primitive, the visualization doesn't work correctly. And if I were to add the visualizer now, let's click on it and let's click this, and here you can see, even though we have visualizer added, it's not going to be visualized because of these packed primitive. And that is why I added the extract all points, just so that I can visualize. The attribute is there, it's just not visualizing. Let's click on it and let's uncheck the active to hide the visualizer. Now that we have the animated active, let's create our bullet solver. In here, I'm going to type the RBD bullet solver, and that is the geometry that I want to simulate. And now we do not need to add the constraint because we are not going to use the constraint, but we will going to be activating our geometry with the active. Let's hit play. We need to rewind and let's hit play. And here you can see all of our changes, this active animated attribute is not going to be imported into the RBD bullet solver. I can go into the properties. Here you can see we have the active attributes, override attributes enabled, and here we have it active. Even though it is listed in here, it's not going to be imported every frame, which means all of the animation that we have just did, these animation, they will not going to be updated. The bullet solver will going to be initialized all of these attribute. If I go into the RBD configure, all of these attribute is going to be initialized at the very first frame, and then the simulation will take care of the rest. To make this active attribute present, to update this active attribute, we need to actually import this inside of the bullet solver. So let's dive inside, and now we are in the dynamics and we are in the forces, and now we can add a geometry warp node in here. Let's add a geometry warp, and here we have it. Let's add this, and we need to connect this in here. Now this geometry warp node will going to be calculated every frame, which means we can dive inside and let's import our active attribute. And we can do so by saying import point attribute. Let's add an import point attribute. Let's go into the import point and we can define the file if we want, or I can just use these context. I'm going to use the op input 1 and I want to import the active attribute, and that is a float attribute. So let's change this to float and let's type the attribute name, and I want to import the active, and let's also write this attribute out by adding the bind export node. Let's add bind export node and connect this. Let me connect this and let's write out this as an active. We have exported this, but this attribute will not going to be imported, as you know, because onto the geometry warp, because we are in the dynamics, all of these warps, their inputs must be defined. Let's go into the inputs onto the parameter of the geometry warp node itself. Let's go into the inputs and onto the input first, which means that because we are using this op input 1, we need to define the input in here as well. I'm going to use the SOP node. I'm not going to use the first context. Let's go back. Maybe let's see, because we are using the first context input 1, let's see if this works. And let's go back and hit play. And here you can see it is working. And now I can go into the bullet solver and let's go into the collision tab and I'm going to add the ground plane. And let's hit play again. And now we are activating these bullet simulation with this attribute, and all of our fractured pieces of geometry is falling apart. And I can go into the transform node, press enter, and let's say I want to start this crumbling effect from there. I just need to place this. I'm going to use this handle and place this in here. Now we'll see that they will going to start crumble from here, and here as you can see, and I can move this into this location, and let's hit play again, and now we have our crumbling effect. And that's how you can animate and import your activation attribute inside of the bullet solver that is available on the SOP.